So this is a huge room, and there's lots of space, so if people want to move up, feel free. That's cool. Like we said, my name is Dave Mango. Dave Mango on Twitter. Really hard to figure that one out. Today we're going to talk about familiar smells I've detected in your systems engineering organization and how to fix them. Really quickly about me, more than 20 years experience in systems engineering, worked on DevOps transformations. I consider myself an international DevOps contributor, meaning like the international software movement DevOps, not the like, hey, you're a DevOps engineer. And so I've written a video course, I'm mastering DevOps, I've contributed to a bunch of books, and my latest thing is I have started my own consulting company recently called Mango Tech, and the things that we're going to talk about today are very applicable to what I'm trying to do as a business, which is basically help people level up their service delivery organizations. And so some of the techniques we're going to talk about today come from places I've worked, either managing SRE teams or other things like that, and then some of the things are from things I've been doing for work. So familiar smells, like why do I call them smells? Somebody asked me once if like I was talking about code smells. And basically what I'm talking about is patterns, right? Smells are one of the most powerful like neurochemical things that we have in our brains. If we like remember, if we smell something, we can bring back a memory from like 20 years ago, and it becomes really vivid and really strong because it's so strong. And pattern recognition is something that we're really good at humans. This is why we have CAPTCHA and all kinds of other fun stuff like that, is we're just way better at pattern recognition than computers or other things. And so like these smells are things that I've seen in different organizations, right? I'll started a new company and somebody will say, hey, we're doing this and we're doing that, and I'll be like, oh, yeah, you're doing this because of this. And they're like, yeah. And I'm like, and then you try to solve it by doing this. And they're like, yeah, how did you know? And I'm like, I've seen these things over and over, and as a human, like we kind of get, pretty good at pattern recognition. And so as a result, like this is going to be a slightly opinionated talk. And so I am going to say things like, you should do this or you should do that. And some people are going to be like, oh, no, like, that's okay. Like, it's not a criticism, right? Like, I'm a very strong believer in leveling people up and, Kaizen principles and stuff like that. But that also means that this talk isn't going to be necessarily for the unicorns. Like, Facebook, Google in the rooms, they're not going to be like, oh, my God, Dave, that was something we had never considered. Like, this is for people who like are going through the process and trying to get better like every single day. Though I'm sure Google and Facebook are trying to do that as well. And so as a result, like you're going to need to do what's best from your organization, right? You're going to have to take kind of hopefully what I say, if it applies, and then use it in a way that's appropriate for you. So a lot of times in my consulting, I'm like, hey, let's choose the solution that's appropriate to your culture. Because like just going in and being like, hey, you need to have a brand new culture from scratch, like that doesn't work. Like just forget about it, it's too much. And so there's going to be some things about failures in here, and that's okay because we learn more from failures. And with that, I got so much trouble in my mind. 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 That darn pager. How many people in here have ever been on call? How many people are on call right now? Oh, okay. Well, if that gentleman has to leave, like in the middle, like we'll all understand, and you as well, and I will not be offended if you have to run out and carrying the laptop like this. Like, that's totally fine. But I've been on call probably a lot more of my life than my wife would care to have had me do. And I've worked at all kinds of different kinds of places, right? I've worked at places where being on call meant that, we get paged like 3 times a week, 4 times a week. Not too bad, you can kind of have a pretty good life that way. I've been, on call where like, I don't know if anyone else has ever done this. You go and you check the monitoring system to make sure that it's still working, because I haven't gotten paged in like 4 days, and like there must be obviously something wrong. Like how could I not be getting paged? It doesn't make any sense. But I've also been, places, I went to the Monitorama conference. I don't know if anyone's ever been there, great conference. Jamie Wilkerson, who's walking around here, spoke there a few years ago. I was sitting next to my friend Mike, and we were listening to these, great companies talk about their stuff that they do, and they were talking about how they were getting paid like 40 or 50 times in a week. And I was like, 40 or 50? I looked at Mike, and I'm like, is that 40 or 50 times? Are you serious? Does that make sense? So, like, this is like literally an order of magnitude larger than anything like that we're used to. Like, I don't understand. And then I worked with a company that got paged 90 times in 6 hours. This is blues harmonica, so that company should have the blues. 90 times in 6 hours. And why do I say in 6 hours? We'll talk about that in a few minutes. But getting paged is bad, right? I mean, getting paged 3 or 4 times a week isn't terribly bad, but like things like this lead to burnout. And burnout is incredibly bad for our industry in general and for people in particular, right? It's bad for our families, it's bad for our social lives, it's bad for our health, right? The levels of cortisol that you get in your bloodstream from being stressed out all the time, these are really bad things for everybody. And so we have to ask the question, like, why are we getting paged so often? Why am I getting paged 40 or 50 times in a week? Do I have bad signal-to-noise ratio? Am I getting alerts about a bunch of stuff that isn't actionable? I mean, that's kind of my rule for my SRE teams. If you're gonna put an alert on my phone, it better be actionable. At 3 o'clock in the morning, I don't wanna get some informational alert, oh, I woke up and now, oh. Yeah, if you have some informational alert you wanna send me, send it to a Slack channel, send it an email, something nice and asynchronous. Please never, ever send a non-actionable alert to my phone. And so people try to do things to get out of this situation, right? Especially if you're like this company that gets paged like 90 times in 6 hours. And one thing people try to do is do this outsourced operations, right? And Jez and Nicole here say, low performers are 3 times more likely to use functional outsourcing. And so I've seen companies try to do this, right? I've seen companies that, try to, let's just get somebody on the other side of the world to handle part of our operations work, right? And so this company that was getting paid 90 times in 6 hours, they had 6-hour shifts that you were on call because they knew people were burning out like crazy. No one's gonna be on call for a week getting paid 90 times, like it's just too much, right? So they would have people on for 6 hours and then another 6 hours, and the overnight shift was some other group of people somewhere that kind of dealt with all this crap, and like that's how they got through it, right? They just kind of outsourced the thing. It doesn't really solve anything, right? You just stay in that situation, like that's a problem. I worked with another group that they took their first level support and they outsourced that to another part of the world, and they were like, I was like, okay, what do you do? Oh, well, we're important. We do the second and third level support, right? The hard problems come to us. Those people, they're doing, the first level stuff. I'm like, well, what is the first level stuff? What are they doing? And they're like, well, 60 to 70% of what they're doing is deleting logs off of disk. Okay, why don't you have a script for that? Well, we do have a script for that. It's just the script doesn't delete enough logs. So we need the humans to go in after that and delete logs. Does anyone else think this sounds like toil? Yeah, so the script goes in and it deletes logs, and I was like, well, why don't you just fix the script? Well, we're getting around to that. We just haven't gotten around to it yet, because we have more important projects, and don't worry, Dave, it's only temporary. Yeah, the road to hell is paved with short-term projects that never died. How many people think that they outsourced the log deletion for 2 weeks? How many people think they did it for 2 months? How many people think that people have been deleting logs by hand for years? Exactly. Because why would they do anything else? There's no incentive to go and fix that. The people who are second and third tier and super special, they're not feeling any pain. Like, the logs are getting deleted, so who cares? Why am I going to take my time and go fix some script that deletes logs if I can just let somebody else worry about it? There's no incentive to fix that. And so people get like into the situation where they think like the fact that these things are constantly broken is just normal. Like, this is it. This is what I do. Does anybody know what city this is? It's Stockholm, Sweden. And so I feel like people get into the situation and they get this like Stockholm syndrome about their infrastructure, right? Stuff is broken, it's not the infrastructure's fault, it's okay, like this is how it's supposed to be. Like I'm supposed to go around and delete logs, or I'm supposed to go around and reboot the Tomcat server. Every 3 days, I reboot the Tomcat server. That's my job. That's how I deliver value to the organization. This is toil, obviously. Like we should not be going around and deleting, logs off the Tomcat server. And so they think that this is their job and this is what they do, and this is what I get paid for, is to go and reboot Tomcat servers. They internalize this so much that this is a quote from the company that got paged 90 times in 6 hours from one of their operations people. We don't have fires. We get new customers. They have a bad experience. They leave. That's just how it works. And I'm like, okay, that doesn't mean it has to be that way. So, my kind of philosophy is just because it's always been broken doesn't mean we shouldn't solve it. So, my, advice, and if you've ever worked with me, you've heard me say this a billion times, don't fix problems, solve problems. And Theo Schlossnagel gave a talk earlier this week, and he was talking about dtrace, and he's like, if there's a problem with a process, don't just restart the process, go in, attach to the process, figure out what's wrong. Because rebooting the Tomcat server, and I'm not picking on Tomcat, I love Tomcat, used it for years, ran great production stuff on it for a long time. Rebooting Tomcat doesn't make sense, if it's gonna happen periodically. If Tomcat needs to be restarted, why? Do I have a file descriptor leak? Am I running out of memory? Is there some kind of memory leak? Is there something else that's going wrong? Let's fix that, or solve that, really, so that we don't have to spend our time doing this kind of crazy toil stuff. So if we're in this situation, how do we get out of these kinds of situations? My philosophy is crawl, walk, run, right? We can't just jump to the end. We can't be like, hey, you know what? We've never run the Chaos Monkey before, but why don't we just turn that on in production tomorrow? It'll be fine, right? I'm sure that nothing could ever go wrong with that. Or I heard Kubernetes is cool. Maybe we should just run that in production tomorrow, even though we don't even have containers yet, right? We can't jump to the end. Who was it? Instagram gave a talk earlier this week where they were talking about continuous deployment, and they're like, you need to have a testing culture if you're gonna do this. And if you don't have a culture of testing, you can't just decide we're gonna go do this tomorrow, right? And so crawl, walk, run is about this idea of delivering value incrementally and working up to the thing that we want to. This is agile, right? As we go on, we learn things, we adjust, we keep maturing ourselves. And so this all comes, Eric Ries and the Lean Startup, all these kinds of things, but we can't just jump to the end. So if I'm in the situation where I'm getting paged 90 times in 6 hours, this is, I'm sure it's hard to see, but it's okay. There's nothing really relevant on there. This is a call to the PagerDuty API, where you can actually make a call, you get back a bunch of JSON, you say give me the, all the alerts that have paged this service in the past 24 hours. And you bring this to stand up every day, and you're like, hey, we've got 12 things where we rebooted the Tomcat server, and we've got 8 things where MySQL is running out of storage, and we've got this and we've got that. What are we going to attack first? What are we going to try to get rid of? Is this just informational alerts? Is it actionable alerts? What's going on here? And we systematically go after all these problems until we knock it down, until we stabilize the patient, right? This is triage from emergency medicine. And once we've gotten to a point where we're in a little bit more of a stable place, then walk would be to go and look at structural elements that are causing this, right? If I'm in this situation where I have my 3 VPs of architecture, engineering, and operations, maybe the VP of engineering is incentivized to release new features all the time, and maybe the VP of operations is incentivized to keep the site up. They don't have the same incentives, right? I wrote Conway's Law on here. This is, Courtney mentioned it earlier this week in her talk. It's basically the idea that the communication patterns of your application will resemble the communication patterns of your organization, right? There are structural elements as to why things are the way they are. If I look at this kind of org chart, my advice to people is take that VP of architecture, take the VP of operations, move them under the VP of engineering. right? Congratulations, VP of Engineering, you are now the SVP of Engineering. You got a promotion, woo! But at least all the incentives are aligned there, right? At least the VP of Engineering can say like, these are the things that are important to me, these are the things that we have to prioritize, and everyone is going to work towards those same goals, as opposed to here where everybody's got their own goals and stuff like that. And then finally, when you're ready to run, you can go to something like Follow the Sun. Sounds like a Dr. Seuss rhyme. But like, do not consider going to like a Follow the Sun model unless you've embraced these things like, you know, we can't say mean time to recover anymore because Allspa gets mad, time to recover, or like SLOs that are global across your organization, right? Your incentives have to be aligned because otherwise this isn't going to work, right? If I had this Follow the Sun model and it's like, you know, 11:45 or 11:55 at night, and my pager goes off, and I'm looking at 45 minutes of rebooting Tomcat servers, and I know somebody else on the other side of the world is going to take over for me in 5 minutes. Why am I going to go reboot stuff for 45 minutes? In 5 minutes is somebody else's problem. Like, I'm done. Like, it's good. I'm going to sleep. But if I have like this, you know, my SLOs there where like the global organization is being held accountable for uptime and availability, and we know what those numbers are, then I can't do that. I can't just punt the problem to be somebody else's problem in 5 or 10 minutes because my whole organization is being held accountable for these availability numbers. So once you kind of get to that level, then you can kind of jump into these like sort of advanced running kind of stages. Untested infrastructure. Man, have I seen this in an awful lot of places. So we should not be deploying changes to our customers that have not been tested, right? I've seen a whole bunch of places where people are like, oh, you know, testing is for software developers and, you know, we're ops, so who cares? Like, no, absolutely not. Like, we're getting to the point now where, like, infrastructure is code, right? If infrastructure is code, then infrastructure has to be code, right? And we have to be able to test the things that we're going to go and do, and we have to have like faith that the things that we said that we're going to do are the things that actually show up when we're running our infrastructure. And so one smell that I've seen that I really, really despise is runbooks. I hate runbooks. I think they stink, which goes along with our smell metaphor. I'm not talking about I'm not talking about remediation runbooks when I say runbooks. I'm talking about procedural runbooks. So a remediation runbook says like, you know, if the service goes bad and you see like these things going in this direction, you might want to check out these services. You know, these are the key metrics for this. Those things are totally fine. They enable humans to think creatively and attack the problem because they have the information that they need. The runbooks I'm talking about are when you have this like Word doc or this Google doc or whatever that says like SSH to the machine, open up this file in VI, do this. Like, you know, it's very prescriptive about all the things you have to do, but at the same time, this is computers telling humans what to do, which just do not like that idea. Like, I tell the computer what to do not like the computer telling me what to do. And so, you know, people kind of go through this and make this super detailed list of things you can do. Well, if you can make that detailed a list, like, why don't you just make a script for it? Like, this kind of doesn't make any sense, right? And so I was working at this company, and I was on call, and that means I got to witness what was going on in production. I don't really understand this model, but whatever, it wasn't my model. And so they were like SSHing onto these hosts, and they were supposed to do this stuff, and they SSH onto this host, and they're supposed to edit this file etc bar. Okay, I guess I can watch this go down. But they can't find etc bar. etc bar doesn't exist, so what do? Well, you know, we're in a maintenance window. We don't get these maintenance windows all that often, so we got to take advantage of it. So let's do the best we can. So they look around and they find a file called etc/foo/bar. I don't know, I mean, it's got the same name, it's in the right kind of general area, right? So, you know, this could be the right thing to do. And so they open up the file and they're like, well, we can't find the section that we're looking for, but there is a section in here that's pretty close to what we're actually seeking, so why don't we edit that? Does anyone here think that's a good idea? Well, they did it anyways. You know, they're humans, like they're trying to do the best they can, and like you can be like, well, why? Why did you edit that file? But like my question is like, why? Why were these people ever put in a situation where they had to make these ridiculous judgments about how to get stuff done, and then, you know, they don't do it, and their boss is like, well, why didn't you do it? And they're like, well, we only found Etsy foo bar instead of Etsy bar, and nobody wants to hear that. Like, their bosses want things to get done, right? And so they're like, okay, well, we know that this is sort of, you know, a little bit dangerous, so we're gonna make it safe by having change control, right? Change advisory boards are useless, according to Jez and Nicole, right? They don't contribute anything. Do you really think like the change advisory board looked at this change that was coming through and was like, well, edit Etsy bar, but if you can't find it, then edit Etsy food? No, of course they didn't do that. And of course, those people didn't even know what's going on. Half of those people are managers. They don't even understand what an Etsy bar file is, let alone like, oh, well, you should have the freedom that those things are crazy, right? And like these change control boards, they don't fix anything. All they do is make your deployments a lot slower. So how do we get out of this situation where we don't have tested infrastructure because we're doing stuff with run books and all this other stuff? Crawl, walk, run, right? That's how we get out of these things. So the first thing is like infrastructure unit tests, and there's all kinds of, I'm not saying these are the only ones, there's like RSpec, ServiceSpec, GOS is like some newer one that's in Golang. Somebody told me at their speaker's reception that all the SREs think Golang is cool these days, so if you want to use that, go ahead, I don't care. But what you don't want to be is in a situation where like I'm, you know, running my infrastructure as code, I'm using my Puppet or whatever, and I've seen this, someone makes a change to something that's completely unrelated to what I'm doing, and my stuff breaks. Great, now I have a production outage for something that somebody else did in another part of the business that had nothing to do with me, right? So we actually need to test our things before they go out. Like if I'm gonna say like edit this file or change this file, I wanna make sure that that file is changed. And containers don't fix this, right? Containers still need to be tested. Immutable infrastructure is not gonna save you from bugs. If your container is supposed to have the Etsy bar file and you're not testing to make sure that the Etsy bar file is there, what happens when you ship that thing to production and the application server is looking for that file? Boom, right? So the first thing to do is to kind of get control over your infrastructure. Obviously do infrastructure as code, but as part of infrastructure as code, it's code. Treat it like code, like do testing. The next step when you've gone from crawl to walk is stages like prod. And I know it's all the rage now, we don't have to have staging environments anymore. I think that's fine for some organizations. I think most of us still need a staging environment, right? We need to have a place where we can test things out. And if you've ever worked with me, stages like prod, stages like prod, stages like prod. If I'm going to configure my staging environment, I'm configuring my staging environment with the exact same infrastructure code that I'm going to use to produce my production environment. It doesn't mean that in production, if I'm running a C4 8x large, that I need to run an 8x large in staging. I can run a C4 large in staging. There's no reason to blow all the budget of the company when you're not going to have that level of traffic. And am I going to catch every single error that I would ever see in production this way? No. But if you ever read like Continuous Delivery by Humble and Farley, right, the furthest to the left that we can catch errors, the cheaper it is. It's really expensive to fail in production. It's really cheap to fail in development. And so I want to push all these things like as close as I possibly can. And so we're going to use like the same kinds of, not the same kinds, the same code in staging as we do in production. And not only that, we're not going to do silly things like, well, in the staging environment it's like this, and in the production environment it's like that. Like we're running Postgres in staging, we're running MariaDB in production. Like why? Like it doesn't make any sense, right? We have to, don't make exceptions for your staging environment. And I know this is hard, and this is a lot of the reason that people tell me like, I don't need a staging environment because the staging environment doesn't look like production anyways. Well, the problem isn't the staging environment, the problem is your approach to the staging environment. Stage is like prod. And once you get to the point where you can stably release things, especially imagine an architecture change, right? We want to move to a completely new way of doing something. We're not going to test that before we do that in production. Are you kidding me? Once we get past that, then we can get to things like automated deployment, right? Dark launches, feature flags, canaries, blue-green deploys, all those things are super awesome. I love working in environments that have all these things. It makes it so much nicer as an operations person. It makes it so much nicer as a developer. Like, everybody wins. And these things are definitely the things that we want to get to when we run. And then, you can still use configuration management for your stateful tiers. But yeah, don't try to jump to this, though, at the end, right? You don't just be like, hey, we can skip over being able to build environments reliably and just go straight to this, right? Gene Kim says that one leading indicator of high-performing operations organizations is being able to build representative test environments on demand. And if you can't do that, then like, what do you care about blue-green deploys? Like, what does that have to do with anything? You're going to have much bigger problems.
I got so much trouble in my mind. I got so much trouble in my mind. I got so much trouble in my mind. I got so much trouble in my mind.
Boring technology. Okay. Who thinks that boring technology is a good smell? Who thinks that boring technology is a bad smell? It's the same people. I will say that I think boring technology is an awesome smell. I think it's wonderful. I love the smell of boring technology in the morning or something. So Dan McKinley, McFunley on Twitter says, we should generally pick the smallest set of technology that covers our problem domain and lets us get the job done. I don't like relying on fancy solutions. Fancy solutions scare me like nobody's business. I think simplicity rules. All of us are working in these like complex distributed systems, right? Complexity is an emergent property of the system. We get that for free. We don't even have to try. Like, all we have to do is like show up for work every day, and 20 developers ship new things overnight. Hey, we got complexity, woo! Like, there's no effort that needs to be involved there. So like, when we're gonna choose like how we're gonna do something, we choose things that are simple because we're getting everything else already, and that helps us reason about things and helps us fix things. And the problem I have with these fancy technologies is they incentivize the wrong things, right? If I've got bonded network interfaces and RAID cards and SAN storage, like, all they're trying to do is keep failure from happening. Forget it. Like, failure happens. You can try to stop failure from happening or whatever. And so I don't like this smell of complexity because it's incentivizing the wrong things. How many people here have configured bonded network interfaces on Linux? How many modes are there for configuring network interfaces and bonded stuff on Linux? Anybody? Yeah, there's 6. And it's like, active, and failover, and this is passive, and this thing's this, and it jumps in as passive to master when there's like so much stuff involved in just like configuring that thing. And how does that thing fail? Well, I don't know, what driver are we using, right? Does this network interface driver behave the same way this other one does when there's a failure? And if I'm gonna have bonded network interfaces, those things are gonna go into switches. And I'm probably going to want those things to be in 2 separate switches because I'm protecting against failure, right? And those separate switches are going to have some kind of protocol that goes between them that knows about the other switch that being there, right? And maybe it's VRP, maybe it's HSRP. And is the network interface going to be actually an add-in card, or is it built on the motherboard? And are they from different manufacturers? And do I know what give me a break. It's 3 o'clock in the morning, I get a failure, and I'm going to sit here and start reasoning about all this level of complexity? Like, how the heck does that thing fail, and whether the thing failed? Like, no, like, forget it, like, game over. We need to learn to tolerate failure, and we need to be able to get good at recovering from failure quickly. That's like what the incentive is. And the problem is when we try to incentivize not failing for as long as we possibly can, we get like what Nassim Taleb calls these black swan events, which this is actually Jez Humble, like summarizing it. He says, these artificially constrained systems become prone to black swans. Such environments eventually experience massive blowups, catching everyone off guard and undoing years of stability, or in almost all cases ending up far worse than they were in their initial volatile state. If we're not used to seeing failure in our environment, and then a failure happens, then it's like everything is panic mode. Everybody's running around like crazy, trying to figure out like, why didn't we have instrumentation on that? And I don't know what this, and there were things that were, I don't have logs, so how do I, like forget it. Like we can't just like try to put off failure forever and then assume that somehow when this failure happens, we're gonna be good at doing anything about it, right? Gene Kemp's third way of DevOps, repetition leads to mastery. I'm not gonna get any mastery if I don't have any repetition, right? And so this idea of prioritizing MTBF over MTTR is backwards, right? It's the same as the cattle and pets argument. So Aaron Blahowiak from Netflix says, so instead of trying to prevent errors, optimize for a relatively frequent occurrence of low impact errors. For infrequently occurring errors, this means we need to induce them. So the more astute people in the room, or maybe more experienced people, will hear the nod to chaos engineering, which we'll get to in a bit. But I want my recovery to be boring. I want my recovery to be simple. If something goes wrong, I want to kill it and have a new one. And I don't want to have to think about it, right? And this is why, you know, we talk about doing infrastructure as code, right? If my web server dies, I want to get a new web server that looks just like the web server that I had. I don't want to sit there and be like, oh, I need a new web server, open up the Word doc, okay, copy this, forget it. Like, that's not simple. I want boring things that just work reliably every single time. And so people get a little bit confused, right? They're like, oh, but, you know, isn't that how a load balancer works? Like, it's just like RAID, right? Disk dies in my RAID array, something dies behind the load balancer, we replace it and everything's fine. No, they're not the same, right? The RAID stuff relies on somebody going and getting that thing fixed as quickly as possible. That doesn't make any sense, right? I like my tools to obey the Unix philosophy of doing one thing and doing that one thing really well. I want it to be simple, I want it to be boring. I don't know how many people have checked this out, like Facebook has a really good talk, and probably a paper, on the billion user load balancer. When components fail in there, they just replace them. That's it. Nobody's going around and doing anything crazy. Facebook wrote Haystack. I'm not a big fan of Facebook in one way or the other, but they wrote Haystack, right? Haystack is for storing their images. And, you know, Haystack has a distributed object store. And when one of the servers in Haystack, I don't know if they're still using Haystack, when one of the servers in Haystack dies, they replace it with something that looks just like it. And that's it. That's the recovery mode. When, if you read the Haystack paper, it's pretty interesting. They talk about how they used to be on all this fancy technology, the non-boring stuff. It was all NetApps and maybe Hitachi disk arrays and all this fun, awesome vendor technology that will save you from yourself and whatever. And they got rid of it. Do you really think that NetApp wasn't banging on Facebook's door when Facebook was getting bigger, being like, I got more stuff to sell? Of course they were. That's how they make their money, right? But Facebook didn't want to do that anymore. They wanted to get to a situation where they could actually recover from failures simply and quickly. It should be boring. And there's lots of things that can do this now. I was in the PayPal talk the other day. The web application firewalls can scale horizontally. That's crazy. Like that's a brand new thing to me. Like I didn't know they could do that. And you compare like something like, you know, Haystack, where you can shoot something, to like, I'm going to go way back, so people who are as old as me, probably this will give them nightmares. But I used to run this database, like for behind this, application server, whatever, that used Veritas Cluster Server. Sounds amazing, right? Clusters. I have a cluster now, so I can fail and everything's going to be fine. Well, Veritas Cluster Server, basically we had like a bunch of fiber channel disks, right? And they were fiber channeled into some card on the primary server, and then we had our secondary server in case anything ever went wrong. And if something went wrong, then the fiber channel disk arrays would like be deported, I think is what it was called, from like the first server, and then imported into the second server, and there was all these consistency checks, and we had to run cables between all the servers, and so the primary knew that it was the secondary was there, but it was like some proprietary like ping protocol. It wasn't like, you know, ICMP, and so those guys would talk to each other, and then like it had to kill processes on the primary because we didn't want Oracle thinking that there was another thing. Like, it's like a Rube Goldberg machine, right? It's like the marble falls into the mousetrap, which hits the iron that goes across the goldfish. Like, forget it. Like, this is what I'm relying on for my production operations, is like some Rube Goldberg machine of things that like is all, well, the vendor said it'll be fine. And like the best thing about Veritas cluster servers, like literally it was a bash script, right? That's how you wrote everything. Like, cause you know, bash is the best programming language there. Like it just is like totally insane. And so like what, you know, why do I have this slide up here? It's to make this point about like simple is good. This is for Route 53 on Amazon. You can create an alias. And so here they're doing, you know, ELB example.com goes to some application load balancer or whatever. If you've ever worked at a company that has at least a decent amount of traffic that goes through an ALB, if you do a DNS lookup on the ALB, you'll see that there's a bunch of IP addresses that are returned, right? It's not a single IP address. And that's because your traffic can be, you know, served by any one of those IP addresses. They all wind up on the ALBs. But if you track the IP addresses for your ALB, you'll notice over time they change. Well, why do they change? It's because Amazon has the ability to roll new components of the ALB in and get rid of your old ones, and they do this all seamlessly. And if they want to get rid of something, they shoot it and they get a new one, right? Obviously, there's probably multiple servers behind any one of those IP addresses, but like the modes are simple, it's boring, it's super easy to get all these kinds of things done. I'm not relying on like some VRRP protocol that's going from, you know, the, you know, Amazon Tokyo to Amazon Virginia. Like, this is none of these like crazy things going on. It's like super simple, like, and you know, you can't run an Ethernet cable that far anyways. But yeah, if they, you know, and you know, like when Amazon's doing this, right, they're not like going to the data center and pulling the ALB out of the rack and putting a new one in to do an upgrade. Like, that's not a thing. And this is why I say like remote hands is not automation, right? Remote, like, oh, we had a failure, get remote hands. Like, do you really want your recovery from failure to be dependent on how fast a data center technician can run 100 meters? Like, oh, well, we're hiring data center technicians. What's your 100-meter time? Because if a disk fails for company X, we want you running through the data center as fast as you can to put a new disk in the disk array, because otherwise we're at a single point of failure, right? That's the problem. You know, the 2 is 1 and 1 is none. Like, if I lose a server, I'm down to a single point of failure. That's a problem. I don't want to be in that situation. If you really are interested in this idea of boring technology for SRE, I know it's a little hard to read, but the Login magazine, the USENIX magazine, and you're all at a USENIX conference, from this past one, not the one that was released last week, there's an article in there. There's also a great article by Laura Nolan about like SRE and using boring technology. So how do we get out of this situation when we're using like fancy technology, right? Well, obviously we can't jump to the end. We want to crawl, walk, run. So I apologize, this picture is a little bit blurry, but this is the HP Moonshot servers. This is from a number of years ago. I was walking through the airport in Chicago, in the United States, and I saw this, you know, this advertisement. It says, you know, it's time to build a server for the next internet. Next internet. I want to be a part of the next internet. That sounds awesome. And I knew that we were actually testing these servers at work. And so I went and asked like the people at work, like, are these Moonshot servers, like, what, you know, what's so great about them? Like, why is this for the next internet? And they're like, yeah, they're okay. And I was like, well, what's the API like? Is it, you know, well documented? Like, can we split the things up with some API calls or whatever? And they're like, API? It's like, what? They're like, no, well, there's no API. There's a CLI. We can, you know, you can get on it like with a CLI and like you can configure it. I'm like, wait, you're telling me that the next internet is going to be configured by a bunch of sysadmins SSHing to a CLI and banging out commands with their fingers on a keyboard? Like, I don't think so. That's stuff that computers are really good at, configuring the same thing over and over the way that we want it, exactly the same way every single time. I'm not doing that through a CLI. Are you kidding me? That's not the next internet. And some HP person's probably going to come out for this, but this is from a long time ago. I'm sure they're great now. But like, if you're going to do like walk, start doing configuration as code for these complex components. And I've done this, so I can tell you it's possible. So configure your mega RAID stuff, your ID rack stuff, your ILO cards, like all these things, configure them as code. In Puppet, they have types and providers. I'm sure Chef, Ansible, Salt has other ways of doing this that are totally fine. But the idea is, if my server dies, and I throw it on the trash heap and put a new one in, I get one that looks exactly like the server I just got rid of. And it's not like me going in like typing things on a CLI to configure stuff, because Lord knows at 3 o'clock in the morning I'm a perfect typist and I read things perfectly and everything's great, because what could possibly go wrong? And then when you're ready to walk, right? Game days, production readiness game days. So what's a game day, right? So make a test plan. Say like, hey, you're gonna bring your new service into production, and the SRE team is gonna sit down with you and we're gonna design a plan for how we're gonna test your new service that's going into production. And we're going to do things like degrade packet loss, or we're going to shut off a network interface, or we're gonna detach an ELB, or we're gonna kill 1 or 2 of the servers in your cluster, and we're gonna see how it behaves. And I guarantee you, like, you're not gonna get this done the first time at the first game day where everything works perfectly exactly as you expected. It's not gonna happen. Like, that's okay, there's nothing wrong with that. But you know, after 2 or 3 times, you're gonna get to a point where like, we expected this, and this happened. That's kind of awesome, right? And the other nice thing about that is that your SREs get to practice remediation. Remember we talked about repetition as the prerequisite to mastery? Like, when an SRE gets to practice, like, this is what happens and this is how I fix it, then when it's 3 o'clock in the morning and that happens, they know how to fix it. As opposed to saying like, oh, it's 3 o'clock in the morning, I've never seen this before, let's go digging through the wiki and see if I can find the thing that relates to this, that I can follow the instruction. Like, forget about it, right? We want to practice this stuff before it happens, and this is going to make your SRE better. Is this going to be like a solution for everything? Like, obviously not, right? We talked about how complexity is an emergent property of complex distributed systems. Things are going to change. But at least you're not going to launch something that's broken. Like, I don't want something broken going out into production from the very beginning. And that kind of goes back to what we were talking about with testing things, right? So your system's going to change. Your remediations probably aren't going to change as radically as your system. But obviously, like, that kind of stuff is going to happen. And when you've done these kinds of things and you get good at launching services into production that your SREs understand, then you can go to run, right? Wow, I'm so ahead on time. This is amazing. Oh, yeah, okay, well, there we go. So Nora Jones says, chaos engineering isn't done to cause problems, it's done to reveal them. The problems are there. If we're doing like, Chaos Monkey and the things like that like are actually exercising these things over time, we're finding problems that are already there. We're not introducing problems. People are like, oh, how can we introduce failures that's going to cause these problems? Like, would you rather find the problems when everyone's awake and available and knows how to fix them? Or would you rather find these problems at 3 o'clock in the morning when no one knew it was there, and then all of a sudden it blew up, and now the people are running around scrambling to fix it? Like, I know when I would rather find out about these things. And so when we get to a point where we can do some chaos engineering, and in full disclosure, Netflix doesn't run the Chaos Monkey at night. They run it during business hours where people are there and available to fix stuff. So if you come back from your talk, this talk, and you go back to your organization, you're like, we should run the Chaos Monkey because Dave said so. And then people are getting woken up at 3 o'clock in the morning, like, don't do that. That's not okay. Even Netflix doesn't do that. But we want to find these problems in our emergent systems because they're changing underneath us all the time. And we want to understand what they're doing so that we know how to fix them quickly. This is going to feed into your SLOs and all the other great stuff that we talk about in SRE. So, highlights. If you want to change stuff, crawl, walk, run. Stages like prod, stages like prod, stages like prod. And choose your incentives. Make sure that people and structures and systems are all incentivizing the behaviors that you actually want. That's it. Yes, I gave the best talk ever, there's no question. I answered every possible thing anyone could think.
I have a question.
Yeah.
Oh, sorry. Just a quick one. You mentioned that you like Unix because it does one thing and does it well, or something to that effect. How do you feel about System D?
What's that?
How do you feel about System D?
System D, yeah. Well, not everybody obeys the Unix philosophy the way that I would like. Okay.
So you mentioned that after a few years doing the same thing, some people consider that the value they had to the company is operations, like always doing the same operations.
Right.
But then when another team comes in and wants to change that, how do you convince them to consider a new way to add value to the company and so to reinvent themselves?
Yeah, so the question, so basically, like, how do you convince people that that's actually not their job, right? So the first thing I usually start with is, like, telling people that they're not going to lose their job. Because that's usually the heart of the panic, right? It's like, well, if we automate everything, what am I going to do? Like, I've got no purpose here once we automate everything. And, you know, my advice to them is like, I'm going to get you a better job. Because, like, if you're not doing, like, the silly, like, toil stuff, like, all day long, then you actually get to do stuff that's fun and creative, that you get to use your brain and, like, figure stuff out. And, like, that doesn't mean that, you know, all those things aren't going to happen. They're just going to happen in another way. And you'll get a better job. You're gonna, like, come to work, you're gonna have puzzles. I always tell my daughter, like, she's like, what do you do at work? I'm like, I solve puzzles. And she's like, what? And I'm like, you know, I come to work and there's problems to solve and I have to figure them out. And I look at all kinds of different ways to solve the puzzle. And so, I usually try to sell people on this idea that, like, you're not gonna lose your job, you're just gonna have a much better job that's gonna be way more fun than sitting around and waiting for the computer to be like, it's time to get up from your chair and run down the hall and plug in a disk.
So one of the complaints I hear a lot from our developers is, I push it to staging, but somebody else had something that they were testing at the same time, so we wouldn't have caught this in staging because staging has something weird going on at every moment because other teams are doing other tests. Do you have any thoughts about that?
Yeah, I mean, like, staging is not going to catch everything. Like, that's pretty obvious. Like, it's not a perfect thing. I think the things that are really valuable about staging is number one, like, you can just find out if things are just totally busted, like, just flat out. The thing I really love staging for, and, you know, this is certainly if you have the capability to spin things up on demand, is, like, major architecture changes. So, like, we've gone through things at places I've worked where and there's actually a great talk that we gave at AWS reInvent about this, is we changed our Cassandra, the way we run Cassandra from, like, the instance store to EBS attached volumes. And there's a major architectural change. Of course, our recovery times from a Cassandra node failure went from, like, 2 days down to under 10 minutes. And we could repair Cassandra node, and this is awesome because Cassandra is a system of record, right? It's a database, and when you can restore your database in under 10 minutes and you're not even worried about it and it's totally fine, like, that's a huge advantage. But, like, going through a major architectural change like that, you need an environment to test those kinds of things in, because I can tell you that we didn't sit down and we're like, well, this is how we've designed it, and so it's obviously going to work perfect, you know, like, was it in theory and practice are the same, in practice they're not? Like, it's just not, it's not a thing. So having an environment to make major architectural changes, which I think is super relevant for all of us as SREs, I think is, like, super important. All right, thank you very much.